Hello everyone, today we're back with another nice integral problem. For the first time, I'll be solving one without a graph. The ones with graphs are harder to prepare, but I actually prefer them, at least they look nice in the thumbnail. Anyway, you can see the question. What is the value of the integral from 1 to 2 of x plus 2 multiplied by the cube root of x squared plus 4x minus 4? Let's move the question to the top left corner and write the solution on the right side. Where should we start with a question like this? A few things catch my eye. Take a look at that cube root expression. Normally it's difficult to take something like that outside the integral. But if you just casually take its derivative in your head, you get 2x plus 4, right? That looks somewhat like x plus 2. It's just twice that. So we can try using the substitution method. Let's say u cubed equals x squared plus 4x minus 4. Now let's take the derivative of both sides. 3u squared du equals 2x plus 4 dx. If we factor 2 out of 2x plus 4 and divide both sides by 2, we get 3u squared over 2 du equals x plus 2 dx. Look, in our original integral we had x plus 2 dx. Perfect. And the cube root part? We already defined that as u. Now let's find the new limits. Using the equation u cubed equals x squared plus 4x minus 4. If x equals 1, the lower limit, then u equals 1. If x equals 2, the upper limit, then u equals 2. Okay, now we have everything we need to rewrite the integral. The new integral is from 1 to 2. Remember, those are u values, not x. We replace x plus 2 dx with 3u squared over 2 du, and the cube root part becomes u. If we take the constant 3 over 2 outside the integral, we're left with the integral of u cubed with respect to u, which gives us 3 over 2 times u to the power of 4 divided by 4, evaluated from 1 to 2. Now, if you plug in u equals 2, you get 6. If you plug in u equals 1, you get 3 over 8. So the final result is 45 over 8. The correct answer is option A. To be honest, substitution in integrals isn't always that straightforward. But in this case, it was pretty obvious. If there's anything you didn't understand, or something you'd like to ask, don't hesitate to reach out. I try to answer as much as I can. See you in the next lesson.